Well, hello there. As you can see, I am a pumpkin. Um, you may even refer me to as a jack-o'-lantern, call me Jack, call me whatever you want, but basically I'm a pumpkin, and today I'm going to show you how to do this. This is what the network looks like. Basically, we're going to be doing some face tracking, and then we're going to be making a pumpkin, and then we're going to be making a face. All right, let's go ahead and get started. In order to track a pumpkin to someone's face, you will need a face and a pumpkin. We're going to start with the face. I'm using these AI generated faces that I got from thispersondoesnotexist.com and put in this video file that just loops just through these beautiful people. And we're going to use this as our face for now. So yeah, let's add a face track. And you're going to see this needs no top specified. So we're going to need to tell it the texture to be looking at. And by default, we get if the face is valid or not, as well as the bounding box UNV and width and height. I highly recommend going to your favorite browser and looking at the documentation for this, because in order to do what we're going to need to do, you're going to need to do these steps, aka download these things from GitHub and create a mesh file. Is this NVF file? You're going to need to generate that yourself. And it also shows you some information on how we're going to get the rendering to match up with our face with these instructions here. So yeah, I would definitely recommend looking through that documentation. So let's start with getting the sphere, which will become our pumpkin, to align with our face. So what we're going to want to do is we're going to want to use aspect correct UVs. And what this does is it basically takes the aspect ratio, and instead of the U and the V going from 0 to 1 and 0 to 1, it's going to make the aspect ratio match. So the, depending on what your aspect ratio is, your V is only going to go up to so high. In this case, we're using a 1920 by 1080, aka 16 by 9 aspect ratio. So in our case, our U is going to go from 0 to 1, and our V is going to go from 0 to 9 over 16, which is like 0.5625. So yeah, we have our face track. Let's make a sphere. Let's add a geometry, and this is going to be our pumpkin head. Let's add a camera, a light, and a render. And so now we can see we have this beautiful sphere. We can composite it over the top of our face, and we'll see that it literally just is just static. It doesn't really change. So like it said in the documentation, we're going to want to set the projection to orthographic, the origin to bottom left, and the ortho width to 1, as well as the aspect correct UVs on the face track chop, which we did. So orthographic, bottom left, 1. And now it's going to be basically centered around there. We can make this smaller. And so now we can use our UV coordinates of our face in order to tell this sphere where it should live. So from here, let's go to our geometry. We're going to take our U and we're going to map it to the translation X. And we're going to take the V and we're going to map it to the translation Y. So now we have a sphere that follows the face, but you can see the size does not really match up. Luckily, we have this information, the bounding box width and height. But the thing is, depending on if you have your landmark set to none or like one of these options, these dimensions change. So if you don't have any landmarks set up, then the dimensions of the face will like actually be different. Like the width and the height will be different. But if you, for instance, tell it to set up the like 68 point thing, and the difference between these is basically the number of facial landmarks. So if you look up this 68 multi-pi markups, if you look that up on Google, you'll probably see something that looks something like this, which basically is a bunch of points on your face depending on they also just sort of basically line up with yeah. But if you have that set up, also let me go ahead and we want to basically only look at the B-box information for now. So we're just going to select star B-box star. And now we only have these bounding box, which is only what we're going to need for these. So we can see the width and height is the same. So in that case, we can basically go to our sphere and tell it that the radius should be there. And then we can just go ahead and map it to both of those as well. Now you'll notice that something looks wrong. It's way too big. It's because this is the radius. As in a radius is like half of the sphere. So we divide this by 2 and you'll basically get something that covers up the face. And if you want, you can mess around with this. So say you want it to be a bit smaller, you can set it to how you want. We can do something like this for now. So now we have a sphere that follows the head. For example, if we were to add in a like a transform and move them around, it'll it'll follow the face, as well as depending on if we make it smaller or not. It gets a bit janky like that, but yeah, basically we have a sphere that now follows our head and lines up. So what's next? Now let's basically use these facial landmarks to put the points on the face. So let's add another sphere. We're gonna add another sphere. We're gonna add another geo. I'm gonna move these down. And we're basically gonna use these as instancing for, also I'm going to have a separate rendering for depending on. So this one, I only want to render geo 1. And this one I want to render geo 2. And so this is going to be our points on the face. In order to do that, we have all of these point UV positions, which map up to these things on your face. So also, if you notice, I haven't done the mesh file thing yet. It basically just depends on how much information you want. And the thing I showed you at the beginning, I didn't use the 68 point markup. I used this 126 point markup. It just has more information. However, I wasn't able to find this online. So I literally just had to like map it out myself, and I'm gonna leave a link to this in the description. So if you want to use the 126 one, I posted on my Twitter. So yeah, feel free to use this diagram. I don't know if there's other ones out there. I haven't found them, so I just had to make my own. Um, but the thing is, in order to use that 126, what's happening? Is it the mesh file? Maybe it's the mesh file. Let's see if we add the mesh file. Will this make it work? No, it's not the mesh file. What it is you need to have the face track SOP enabled. And so that will basically allow, I'm not sure exactly why it needs that, but basically it needs this to process something in order to get the information. So now we can take like a select. We basically only want to get these point information. So we can go ahead and select everything with a point. And for instancing, we're going to want to make these into a string of numbers instead of this like giant list. So let's do that. We're going to use a shuffle sequence every second channel. So that basically takes all the U values, puts them in a line, and puts all the V values and puts those. And this is stuff that we can now use for instancing. So, and we can also composite this over those. Let's make this small, like very small. And then we can go instancing, enable it. And there we can see we have a bunch of spheres that follow the face. We can just put like a constant material. Make these even smaller. And we're actually, let me go ahead and make you back bigger. So we have the whole face included. So now we basically can have, you know, a bit of a bootleg jack-o'-lantern, if I may say so myself. You can also sort of see here the difference between the 126 facial landmarks and the 68 point facial landmarks. So basically the 126 has more information around the cheeks, as well as more information in the eyes and around the mouth. So, you know, pick whichever one you think is going to work best. When we're making the jack-o'-lantern face, what we're basically going to do is isolate specific ones of these to make the face. For now, let's make this look like a pumpkin. You know, I'm sure you could if you wanted to get crazy with geometry and modeling and, you know, select these edges and extrude them outwards and, you know, make it pumpkin-y, but we're gonna do a bit of an easier way, which is gonna be all through materials and displacement. So basically we're gonna make a texture map that's going to tell this sphere how to displace itself to look like a pumpkin. In order to do that, let's get a ramp, and this is going to become the base of our texture. So watch this. You can do something like this. You can do something like increase the period a whole bunch. And then let's put this to a null, And then from that null, we're actually going to need another null. And this is going to be height, the height map. And then let's take a normal map. And the normal map, and put this to a null too. This will be our normal map. So if we go to our material, right, because we need to first do the normal map. Enable height map. Height map. Now you can see something that looks like a bit like the start of a pumpkin. We have this bump scale, which we can use to make it look more or less bumpy. And if we turn on displace vertices and dial this way back, you can see we actually have these vertices sort of displaced. Now, this is very regular. It's a bit too regular for me. I want to add a bit of noise to make it look more, you know, like an actual pumpkin and all bumpy and weird and stuff. So what I like to do is just displace it with some noise, turn off monochrome, turn the displace way down. You know, maybe something like this or so. And now sort of you can mess around with the parameters here to get it looking like you want it to, you know, depending on how bumpy you want it. You can mess around with this noise, mess around with the amplitude, the period, want it smaller, bigger. Yeah. Yeah, so what I'm gonna do is I'm gonna turn this displace down even more. I really want it like a bit, something like here. We could turn the bump around there. And if you notice at the bottom here, it's a bit, it doesn't look the best. And an easy way to fix that is if let's add in a composite. Let's add in a ramp. And then we're basically going to use this as something to soften the bottom a bit. You know, you can use this ramp to sort of smooth out that bottom bit to your liking. Too much. Something like that. Something like that will work. So, yeah. a pumpkin thingy. Now we can, if you would like to add a little stem to the pumpkin, let's take a tube. We're gonna give it a geometry. And we want this to be positioned at the top of this sphere. We can use the information that we have here to control the placement. So let's say, let's copy. Let's copy here. I want to make these the same, so I only have to do one. And then let's make this by like a lot smaller. And then for the height, we can take the bounding box height. And then also multiply that by something like that. We're also going to want to take this tube, because right now it's sort of in the middle of this. If we put the center also to this, oops. Put that there. So now you have a tube, stem, and you could mess with the proportions just to sort of get get something you like and something you're happy with. This will work for me. Let me get another material for this. Boom, material. Make it green. Boom, it's green. Right, we don't have tangents on our pumpkin. So let's do an attribute create, compute tangents, which will make it look a bit better. And then also let's let this render the thing we added. Yeah. Okay, so we made the transforms of these the same. So now you have this little pumpkin head that follows the face. Got a little stem. You got the little pumpkin thingies. And what's next? Now to make it truly like a jack-o'-lantern, we're gonna want to make it have faces that face features. So in order to do that, let's work with this. So to start off with, let's sort of take a look at this and see Let's see what features you think we could use to make a jack-o'-lantern face. So we're gonna want some eyes. So we're probably gonna want these eye ones. We're probably gonna want these eyes. We're gonna need some sort of nose. And then we're gonna need some mouth coordinates. Let's start with the eyes. How do we get just the eyes? Well, what we can do is we can filter it. We're gonna want a different expression. How about this? Here we go. So say we want points 1 through, like also if you look on the face, you only have the point 1. You know, we could do points 1 through 5. We get those points. So basically this is how we're able to isolate what we want. We pull back up our handy dandy note thing, we'll be able to see that if we want the eyes, we're gonna want 65 through 81. So let's do 65 to 81. Also, you'll notice if you do that, you get a message here that says instance attribute yada 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 can be found. Basically, it's because these numbers are changing. An easy solution for this to make it not really matter is just to rename it. We rename it to face U and V. And so now if we go into here, we can change these. So now no matter what we select, you know, to 87, it really doesn't matter where you start and where you end, it'll all match up. So we got one eye. Okay, cool. What's the coordinates for the next eye? So we got 65 to 81, and then the next eye continues from 82 to 98. So we can just go from 65 to 98. Boom, we got eyes. Okay, we're getting somewhere. What about nose? Let's look. The nose goes from 52 around here, 52 to 64. Let's try that. We can go comma, 52 to 64. Leave that space out. And here you get the nose. Personally, I thought it worked best with just like a little small nose. It is a jack-o'-lantern after all. So I just stole one of these points. You know, you could do 54 or 55. I just, you know, pick one of those. I thought that worked pretty well. So now we have eyes and a nose, and now we're gonna want a mouth. And now the mouth, let's see, where does it start? Here you go. We got from 99 around to the hundreds around in here. So let's say we want from 99 to 118. Let's go 99 to 118. So now we have a mouth, and this really is up to you, you know, depending on what values you want. If you even want to, you know, if you don't want to use the more complex version, if you just want to use these 68 point, you know, it's going to be different, but it's really just up to you on what information you think is going to look best for your effects. Okay. Next, we have these. Let's make it like, you know, yellow. There you go. That's a bit more jack-o'-lantern-y already. And we can also increase the size of these to get something a bit more, looks a bit more pumpkin-y already. Looks a bit more pumpkin-y already. So I mean, this is sort of the baseline. There are a few things that you could do to increase the detail to make it look even better. And so, yeah, let's do that. For example, if you wanted to add a edge, make the edge, you know, some kind of orange or whatever. You do something like that. And you can also basically do something similar to how we have here. And if we displace this, we can make it look a bit, you know, make it look a bit wonky if you want. You know, depending on what you exactly you're going for. I found, you know, low, something like that looks pretty cool. Looks a bit more carved into, but you know, you could really not really play with it and to get something like you would like. Also, if you want to make it look like it has a bit more depth, something that I had did in my original effect was I took a circle, make this some sort of smooth resolution, and we can do the same thing we did before with this. So something like there. So in order to get this circle to line up, because the circle goes from 0.5 to 0.5, and these are currently set up not like that. So let me go ahead and let's do some math only on the U and V. We're gonna take these from range 0 to 1 to from 0.5 to 0.5. Take this, plug it into the composite. You see it doesn't quite line up. Why is this? Well, so yeah. Some next steps, if you would like to take it further, you can add some depth to it by taking this circle, which we had to remap. First, we had to remap the V coordinate to match our aspect ratio, which is 9/16. It depends on here. You see our aspect ratio is 16/9. We would want to remap it from to here, and then remap that from negative 0.5 to 5 on the bounding box UVs. So in order to like put the 2D shape or the 3D shape, it's a bit different. And we can use this circle and mess with the softness as well as the size. I found something like this works pretty well. What we're gonna do is sort of fake act like there's a back of the pumpkin. And the way we're gonna do that is we're gonna add a lookup. And a ramp. And then we're basically going to tell it to go from like the orange to yellow. So something like this. And we can use this to affect this. And so here now you kind of have a bit of a, it looks almost as if it's glowing from the inside. And yeah, you know, you can mess around with these colors until you find something that you think works well for you. So now it has a bit of a depth to it. You know, you could also take this softness and add like a noise to it, make it look like it's flickering. Basically take a noise, time slice it so you have a noise that goes from -1 to 1, and then remap that to sort of fit the flicker that you want. So we can say yeah, you know, mess around something like that. So now we got a little flicker. You can also, if you move the displace before that, if you do that, you get a bit of a noise in the background. Almost looks, you know, like the pumpkin walls or whatever. So yeah, this is the basic idea of the effect. You have a pumpkin that is on somebody's head. You know, happy Halloween. Some other things you could do is, you know, you could add some noise. Don't really need too much. You know, now you get a bit of a different shaped pumpkin, you know, if you want to, you know, make it a bit stouter, shorter, more pumpkin-y. Give the stem a bit of personality too. You could also do something like this and smooth out the top of the bumps, displacement.